In front of us, we have the model that we built in Module 2. Now, before we make any kind of modification to this model, let's change the time setting. So if you go to the Model menu up here and click that, and then there is a menu that says Setting, and it allows us to change the time setting for this model. So far it is set to run for 60 days. However, we want to change that to 360 days so that we get to see in a slightly longer period of time what's going to happen to the people who show symptom of COVID-19. Okay, so we're going to change it to 360. And then before we move on, I want to just run the Module 2 base again with this new time setting. So since we changed the time setting from 60 days to 360 days, now we want to run the base run again so that that new timeline is applied to the simulation results. Okay, so that's the first thing that we're going to do. Now we ran the simulation, we can take a look at the result of our base run. You can click each stock or variables to see what happened, like this. Now you see that the timeline is way longer, and you can also go back to the control panel and take a look at the graph that we created from the previous module. And if we display that, it shows the graph of susceptible population, infected, asymptomatic population with the incident rate and the symptom appearance rate all in one graph. However, it's harder to see the dynamics because now everything is kind of shifted in terms of the timeline. So we are having 360 days and everything is happening within the first like 70 days. So it's kind of hard to see what's going on, but we will go from here. Okay, now our model is ready for new modification. Okay, so the first thing that we're gonna do is we're gonna create some new stocks. Okay, so I would like to delete this cloud sign because we're gonna expand this part. Okay, now we're gonna add level box variable, which is reserved for stock, and my first stock that I'm gonna add will be infected, symptomatic population. The next stock that we're gonna create is gonna be recovered population. And some of you might actually see that you don't have enough room on this side of your screen. Now what you can do is you can actually grab everything, okay, and then move it to either your left or right. And what that does is it actually expands the screen or the sketch area. Okay, so if I move it down here, and then you see how that my sketch pad has expanded. So that's what you can do when you run out of room. Okay, and then I'm gonna make another stock down here, and that's gonna be cumulative death. Okay, so this will be the total count of people who died from COVID. All right, now let's create flow rates between these stocks. So we're gonna use the pipeline. It says rates, and then this infected symptomatic population comes from this infected asymptomatic population. We already have the half of our arrow here, so you can click where you have the valve, okay, and it's gonna continue this outflow into the infected symptomatic population. So when you are creating these pipelines, make sure they are physically connected to the stocks. Otherwise, your model is not going to run correctly. Okay, and then the next one will be from infected population to recovered population, and the name of the flow will be recovery rate. All right. So I'm gonna move this a little bit. Okay. Now the next one is from infected symptomatic population to the cumulative death, and that's gonna be death rate. All right. So these are our pipelines. Okay. Now, in order for us to define the recovery rate and the death rate, we need to know out of all the outflow from the infected symptomatic population, what percentage of people will go through the recovery rate route and what percentage of people will go towards this death rate route. Okay, so because there are two different outcomes, we need to know the fractional death rate, which will determine the percentage of people flowing out of this stock that's going to go down here. Okay, so we're going to add that variable, and it's going to be called fractional death rate. Okay, so that's going to have an impact on our death rate as well as the recovery rate. So if the fractional death rate is, let's say, 0.05, like 5%, then the recovery rate will be 1 minus fractional death rate, which will be 95%. Okay, so later we're gonna actually define this as 0.024. Okay, so that's the first part. And just like, how we define the symptom appearance rate in module 2, we're going to use the similar kind of formulation for recovery rate and death rate. So let me just move this variable to up here so that we have some room down here. Okay, so what I'm going to do is I'm going to grab my hand icon and grab time to show symptom, and I'm just going to move it up here so that we have some room down here. Okay, now the variable or time constant that we're going to be adding, the first one will be average recovery period. So on average, how many does it take for the symptomatic people to recover from COVID? Okay, and in initial version of Alice model, this is set to 10 days. Okay, so what's going to happen is every day 1/10 of this stock, okay, will recover. However, that's not accounting for this allocation formula, which will divide up all the outflows into these two pipelines. Okay, so we are seeing this feedback loop here. It's a balancing feedback loop. So basically, more infected population that we have, we're going to have more number of people recovering per day. And as more people recover, we're going to end up with less infected symptomatic population. So there is a balancing loop right here. Okay, so now see how this is very similar to the structure that we used on this part. So the next time constant that we're going to be adding here is called average time from symptom appearance to death. All right, so this is number of days. On average, it's going to take a person showing symptom to not survive COVID. Okay, so we create similar kind of arrow. Okay, so it's just on the sideways, but exact same logic as here and here. Okay, and then in Alice model, this variable is set to 7 days. So that's the basic setup. So let's just define the equations. So first thing that we want to take a look at is infected symptomatic population. So you just open this, okay? And in the beginning, we would have a 0 number of infected symptomatic population. And you will notice that new outflows are added to the intake box. So it's an inflow, which is symptom appearance rate, minus death rate, minus recovery rate. And then the unit's gonna be persons. Okay. Now, recovered population, in the beginning we have 0, and then it only has inflow, and the unit's gonna be person. Okay. And then cumulative death will be also a sum of all the number of people die on a given day, and then initial value will be 0, and then unit's gonna be persons. All right, now the fractional death rate, we're gonna set it at 0.024, and the unit here is, since it's just a fractional rate, we're just gonna set it at what's called the dimensionless, so it doesn't really have a unit, okay? And we gonna say okay. All right, the average recovery period, we're gonna set it at 10, and the unit's gonna be day. And then average time from symptom appearance to death, we're gonna set it as 7, and unit as days. Okay, now let's do the death rate first. So if you click that, okay, your equation is gonna be total infected symptomatic population, okay, and then you're gonna multiply that with the fractional death rate. Okay, so this is the number of infected symptomatic population that's actually gonna go towards the death pipeline, and then you're gonna divide that by average time from symptom appearance to death. Okay, so the unit's gonna be this whole part in the numerator, that's gonna be person, and then you divide that by day, so the unit's gonna be person per day. Okay, and your recovery rate is same thing, so it's an infected symptomatic population, but this time you multiply that with, and you want to open parenthesis, it's gonna be 1 minus fractional death rate, okay, and close the parenthesis, and you're going to divide that by average recovery period. Okay, and then your unit's going to be person per day. Click OK. Now we are done with this part. Okay, I want to make few other changes though. So before we move on, let's save our model. Okay, I'm going to save this model as module 3. Okay, now we want to change the context between infected and susceptibles. If you remember in module 2, once you start showing symptom, you didn't make contact with anyone and you just flow out of the system. However, that's not the case here. So when we are talking about the context between infected and susceptibles, those infected actually include infected asymptomatic people and infected symptomatic people. So we wanna add this stock into our formulation of context between infected and susceptibles. Okay? Well, later on, we will modify that once we incorporate quarantining in our model. So when you have symptom, then you can quarantine yourself, and maybe you're gonna contribute less to the context between infected and susceptibles. Okay? However, at this stage, both infected asymptomatic and infected symptomatic, they're gonna have same rate of contact with the susceptibles. Okay, so that's the first assumption that we are making in this model. Second one is when people recover from population, they remain in this stock and they're not going to return to susceptible population yet. Okay, what that means is once you have COVID and recovered from COVID, you are immune to it and you're not going to get it again. Okay, so they are in this stock and they don't really influence other parts of the system. Okay, however, in the next module, we're going to modify that because we know a fraction of people recovered from COVID, they can contract the disease again, right? So we will actually add a pipeline going back to the susceptible. Okay, now the death rate and the cumulative death, right now, we are collecting the data on this information. You know, how many people have died from COVID from the start of the pandemic. However, it's not really having any impact on the rest of the system yet. Okay. However, in our future module, what we're going to do is we're going to actually change people's behavior based on their observation of the death rate. So if the death rate goes too high and if it really scares people, then they're going to start adjusting their behavioral mode, and then maybe they're going to lower their number of contacts per day. Okay, so those things will come down the road. Okay, so far we have a simple model where contacts are made between susceptible and those two stocks of infected people. And what we want to do right now here is adjust the total population. So this is a set number at 80 million people, right? So what we're going to do is we're going to change this variable to initial population. This is where we start the population. However, we're going to create this stock of population where there is an outflow of people due to COVID. So we're going to call that death. So this is the number of people who are dying due to COVID, and we're going to subtract that number from population. So this is in a way closed system where population isn't going to change based on birth and natural death or death due to other reasons or migration. So population is a set number. Only change that we're going to make is the COVID related death. Okay, so this death so this outflow of death is coming from the death rate here. So we're just gonna link the two. Okay, so they're gonna be equivalent. And then the initial value of our population will be determined by this initial population. So I'm gonna add that arrow here. And then I'm going to break this link between initial population to the contacts between infected and susceptibles. And instead, I'm going to create a link from the population stock, which accounts for the death of people, and put that into our equation. So when we are calculating the contacts between infected and susceptibles, we need to calculate for the fraction of infected people in population in general, right? That determines the probability of the susceptible people making contact with infected people. So that population number should account for the number of people who die from COVID. Okay, so that's the change that we will be making. Okay, and then I'm gonna turn this arrow into gray, just like these. Okay, because these just refer to the initial value of our stocks. So the population, if you open the stock, the initial value of population is gonna be initial population. The unit's gonna be person. Okay, and then you can set the death equivalent to the death rate. So that's gonna be in the equation box, we're gonna put death rate, and the unit's gonna be person per day. Okay, and then the context between infected and susceptibles, you can open that up, and then you're gonna change this so that in the infected asymptomatic population, we actually gonna add symptomatic population. Okay, so this is the total number of infected people, and we're gonna divide that by not initial population but population stock. So this is the modification that we're gonna make to the context between infected and susceptibles. You don't need to change the unit, it's gonna be the same. Okay, now you can save the model. You can go and check your model, and it's gonna tell me that the cumulative death, okay, is not used in any other part of the model, which is okay at this point. It's just letting me know. And then if you do the unit check, it's gonna tell me my units are okay. Okay, now I'm gonna run module 3 base. So go to sim setup, change the simulation result file name and simulate. Okay, and now you can see what happened to your susceptible population. So this is module 2 base, and this is module 3 base. And you can see that the epidemics is happening a little faster. That's because now the rate of contact is getting high, because now everyone showing symptoms is also making contact with the susceptible people. Okay, and then if you take a look at the death, this is what's gonna happen. So we are gonna have maybe the total number of people who die from COVID is you know, it's in the between 2 million and 3 million people. So if you take a look at the recovered population, now it's a little less than 80 million, because those are the gap between the 80 million, which is the starting point of our population, and then the whole recovered population, the gap that represents the people who died from COVID. Okay, so I'm gonna show you how we can create a graphs that's gonna give us some insight into this model. So go to control panel, and then you can go to the graph tab. Okay, and then here we're gonna create a new graph, and now let's create a graph that compares all the stocks. Okay, so stocks in module 3. So they are gonna be, let's start with susceptible population. Okay, and then the next one is gonna be infected asymptomatic. Next one is gonna be infected symptomatic, and then we're gonna add recovered population, and the last one that we're gonna be adding will be the cumulative death. Okay, now we want to lock the scale of all these populations, but we might not want to lock the cumulative death with the rest of the stocks, because this one has such a different scale compared to others, and if you put them into one scale, one graph, then we might not even see any changes in cumulative death. It's gonna just show up as a flat line closer to 0. So I'm not gonna lock cumulative death with the rest of the graphs. Okay, now click OK, and now let's take a look at our graph. Click stocks in module 3, and we're gonna display, and this is what it looks like. So as you can see, most of the behavior, it kind of take place within like less than 100 days. Okay, so if we cut the graph like right here, we might be able to see better what's going on, right? Since here on this part, nothing's really happening. So what I'm gonna do is I'm gonna modify my graph and go and say my x-axis minimum will be 0, but I wanna make my x maximum to, let's say, 100. Okay, click OK. And then let's do display. And now you see more clearly what's going on here. So this is the number of susceptibles, okay? And eventually what happens is people will either get COVID and recover from COVID, that's this gray line, or they're gonna die. So that's the black line. It looks like it's a lot, but it's actually using the scale. So the other graphs are using 0 to 80 million people on the y-axis. The death is using 0 to 3 million in the y-axis. Okay, so you can take a look at that. And you can see how people are moving along the pipeline, starting from susceptible to the infected or symptomatic, and then they move to the infected symptomatic, and then to either recovered or to cumulative death. Okay, so that's what's going on in module 3. We can create another graph that just shows all the rates. That's gonna be interesting too. Okay, so in this case, our first rate is gonna be incident rate. The next one's gonna be symptom appearance rate. And then we're gonna add recovery rate. Okay, and then we're gonna add the death rate. Okay, we just wanna see how things are changing. Okay, just the pattern and not really on specific numerical value. So I'm not gonna lock the scale here, and I'm gonna set my x maximum to 100 days. Click OK, and let's see what happened to rates in module 3. And then you can see that how people are moving through the pipeline. Okay, starting from incidence to symptom appearance to recovery and death rate. Okay, having said that, again, all these graphs, they have different scales. So we have to be mindful of that. Okay. Now, another thing that we can do here is compare what happened in module 2 and module 3. So let's see what happened to the incident rate. So what I'm gonna do is create new, and in this case, comparison of incidents. The incident rate is a very important data to follow because it shows the number of new people getting COVID on a daily basis. Okay, so we're gonna click incidence rate. Okay, but the data set will be module 2 base, and then we're gonna click another incident rate, and this one's gonna be from the data set module 3 base. Okay, and then we're gonna lock the scale, click OK, and then comparison of incidents. If you display, okay, it's hard to see. Let's change the x maximum to 100. Click OK. Now display. And this is what's going on. So compared to module 2, module 3, things are happening a little faster. You're having a lot more people infected with COVID. That's because people with symptoms, okay, they are still in the mix of people making contact with the susceptibles. Okay, so once we make those changes of quarantining or recovered people getting COVID again, or people changing their behaviors based on their observation of what's going on in the system, like all those things will have impact on this incident rate. Okay, so we will reflect those changes in the upcoming modules.